Hey everyone, thanks for joining. We're gonna give folks just a moment to make their way in, but in the meantime, I'm Jake. We'll be talking today about remote monitoring for protecting your watershed. We'd love to hear if there's anything in particular that you want to be sure that we get into today. So you should see the Q&A at the bottom of your screen. So feel free to drop in there where you're calling from and what you want to make sure we get into. Kate is here on the line with me as well, and she'll be helping with our Q&A at the end after we go through a little bit of a demo here. But again, for folks that are just joining, feel free to drop in the Q&A anything that you want to make sure we get into together. While we're waiting, I would love to hear as well. We put together just a little poll here to help us get started. So I'd love to know if everyone can see that, I hope. What sorts of issues you're monitoring in your watershed? I know there's a lot of different folks who might be joining us here from different geographies and working on different issues. So feel free to jump in there as well if there's something that you want to hear so we can take a look. But I'll leave that up for a moment as we get started here. So like I said, my name is Jake Faber. I've been working here at Upstream Tech for about the last, oh, you know what? Let's see. Relaunch the poll. There we go. All right. Let me know if you can see the poll now. Hopefully that worked. And Kate, maybe if something's funky on the back end, you can help me out with that as well. So great. Okay, glad to hear it worked. So let us know what sorts of issues you're monitoring for in your watershed. Like I said, my name is Jake Faber. I've been working here at Upstream Tech for about the last 3 years or so, helping conservation organizations to get their hands on these different tools that can help to support remote monitoring across any kind of conserved land and waters. So to give you a little bit of a background of what we do here at Upstream, we're a mission-driven technology company, and we develop tools that help to accelerate the pace, the scale, and the impact of conservation. So we have a team that's got a ton of experience in different areas from remote sensing to land conservation. And we're really excited to talk more today about how we can help to make remote sensing as easy as possible and accessible using this tool that we've developed that's specifically focused on conservation and resource management. So before we jump into how we do that, I will end the poll here so we can all take a look. And it seems like there's a pretty even balance here of what folks are interested in. So we'll be sure to spend a little bit of time on each of these, but monitoring things like riparian buffers, floodplains, algal blooms, pollution. The folks that mentioned other, I would love to hear if you can drop in the Q&A what specific concerns you're working with in your watershed that we might be able to help you out with. So I will turn that off for now. And again, please do use that Q&A section to help us be able to get into some of the issues that matter most to you guys. So let's get back into sort of the basics here though. So talking about what Lens is exactly. So like I said, Upstream developed Lens as a really easy to use web-based application that serves as a one-stop shop for all different types of satellite and aerial data, especially the kind of data that's really hard for conservation organizations typically to get their hands on. So that's kind of where we focus a lot of our effort is on taking these tools that have a lot of really obvious application for the kind of work that we do and bring those down to earth so that you can actually make good use of them. Along with that, we developed a streamlined tool for monitoring, planning, and analysis as well. That's all built in there. So I'll show you how all those different features work as we go along. We talked about remote sensing data. There's a lot out there, of course. So we are primarily working with data vendors that include some names you may have heard of. So Maxar, Airbus, Planet, Nearmap, some of these types of organizations that are producing some really high quality data that we can get our hands on to help us better understand the places that we protect. Give you a little idea of what that actually looks like. Here's sort of, I feel like a nice comparison to start out with. There's obviously a huge range of different types of data, specifications, resolution, different kinds of things. And something I always like to start out by saying is that at the end of the day, in the work that we do, the questions that you're trying to answer should guide the methods that you use. And so what we try to do in Lens is provide access to as many different data sources as we can so that no matter what you're working on, you can find something in here that's going to be able to help you to understand those places that you're working in. So how we actually apply this then, can look like a lot of different things, but in particular, we can really easily observe changes on the landscape. So for instance, I know a couple folks on the line are familiar with this sort of issue. So this is a concentrated animal feeding operation, or CAFO. Particularly, these are used to grow large numbers of poultry in some states, and they can pose some really big issues if the waste that comes from these facilities isn't properly managed. So being able to get an eye on where these new sites are cropping up in your watershed and how they're managing waste can be really important. So that's the kind of thing that we can take a look at in Lens really easily. And going beyond just that visual comparison, we also can analyze longer term changes that may be a little harder for us to see with our own eye. So this is an example from Bangladesh where we can see that there's been some changes in particular right here, we're seeing changes in mangrove forest cover. So this is a really important wetland species in a lot of tropical areas. And in this case, we can see where that erosion over time into that area that had been dominated by mangroves has ticked up. And we can measure that change here using surface water indices. Going beyond just analyzing areas we're interested in, we also can use some of the tools in Lens to help us get automated alerts when there have been unexpected changes that we might not have even known to look for. So here's an example from a working forest in Northern California where there's a pretty large harvest. And so we can see in red the area where Lens identified a clear cut that occurred. That's the kind of thing that, especially in these more mountainous areas, may change some of the hydrology here in ways that are going to affect some of these smaller headwater streams. Once we've done all of this work, though, whether that's getting our hands on some data just to sort of see what changes we can notice in the landscape, doing different kinds of analysis and so forth, we can also take all of those insights and share them out really easily. I know in a lot of the work that we do with watershed protection, making sure that we have really clear insights to share with our communities and with regulatory agencies can be important. So that's also built into the process. To give you an idea of who has been using Lens to do this kind of work, we have about 250 organizations that we work with today. A couple of folks on the screen that you may be familiar with. And overall, we have about 220 million acres that are being monitored in Lens globally right now, which we're really excited to see. So with that, let's hop over to actually take a look at some examples here. So I pulled up a few for us to start with that are going to speak to different issues like the ones that we were mentioning at the top here. But maybe to start us off, give you a little orientation to what Lens actually looks like and how it works. So like I mentioned, it is a web-based application. The idea here is that it's really easy to use, doesn't require any sort of advanced geospatial data training, and it's something that anyone on your team can get into so that they can really get down to business and sort of answer the questions that they have about sites that could be anywhere in the world. So here you'll see that I have different portfolios set up where I can manage different projects, for instance, related to wetland restoration. If I want to go into this portfolio, I can see different sites that folks on my team might be monitoring. And when I go into one of those in particular, so let's start with this one here from Ohio as a bit of a sort of straightforward, good one to start with. This is where I'm going to be able to see some of the changes that have been happening on this site over the last couple of years. So first thing that happens when we get into Lens is that we're going to be able to tap into some of the publicly available data that loads up for us to use right away. In this case, I'm looking at an image from July of 2009 from USDA, and I'm comparing that to another image from June of 2021. And what I want to bring your attention to is right over here. So as I toggle this slider bar, we can see the changes between those two, the before and after time steps. Right over here along the side of this road, we can see where that river has sort of been eroding away at that stream bank and encroaching closer and closer to the roadway. That's something that my colleague Eve identified here. And if I pop over to my notes, I can see where Eve started to make these observations. So I can go back and see the same things that she was looking at. So to start out, we used some of that publicly available imagery to understand what has been happening here over the last handful of years. And then what we started to do was to say, well, how has this changed more recently and what's been done? So in particular, in August of 2022, Eve noticed that there was a project that had been completed to stabilize that stream bank. So right here, we can see where that work has taken place. And then she also pulled an image from 2 years later to see what that looks like more recently. We can see that this area has been reseeded and that stream bank still is holding that erosion back. Right now, I'm looking at an image from spring of this year, and this is from one of our partners, specifically from Airbus. So this is commercial data that we can access really easily in Lens by coming over here to this border tab. So something that I can do from here is see what all of these different vendors that we work with have already captured in terms of imagery that's available for this specific geography. So here I can see a bunch of different options that I have to choose from, but if I want this recent one from Nearmap, 50 centimeter resolution image that's captured at the beginning of last month, I can pop over here to get a preview of what that looks like. And I can see that for the 38 acres worth of imagery, I can pay just about $2 for that, and then have that available for me to work with. So as I've gone along here, I've sort of added the site that I'm interested in seeing, pulled up some of the public data, some of the commercial data, and then we can make different observations about what we've noticed. Really straightforward. I wanted to hop to another site that I've been spending a lot of time looking at recently. This is the River Arc District in Asheville, North Carolina, which a lot of folks are probably familiar in the last couple of weeks, especially has had quite a lot of really damaging impacts they're dealing with as a result of the hurricane earlier this month. So I actually used to live in this area, and for a while, this is my go-to example for urban greenway projects and other really exciting types of infrastructure work. And so you can see here that I was particularly interested in what was happening along the river. This is the French Broad River, North Carolina, right here. Hop over to my notes so I can see what it was that I was looking at a little while back. And I'm going to go through chronologically, sort of show what I had noticed over time. So in particular, you can see over here, back in 2021, was when I was interested in tracking some of the changes here, where if I zoom in, you can see some of this development that hadn't existed before. So it really made great use of the space for recreation, especially in the floodplain that has been known to experience flooding in past years. However, much more recently, we saw something like this. So here's our before image. So this is from the end of September of 2023. So to give you a year-over-year comparison here, this is what this looked like in the immediate aftermath of that hurricane. There's a ton of flooding here that came through. And something that you can see is that obviously that water level is quite high, right? With our notes, we can also add context for what we're seeing. So I added the stream gauge data from the French Broad River, and we can see that here, this river crested at about 25 feet. When I am looking at this image right here, something that's really helpful with a lot of the satellite data that we can get our hands on, is I can come over here to see the details of when exactly that was captured. And so I can see that this image on the right was captured by Planet on September 29th at 10 a.m. local time. So that gives me a really specific way to go back and say that I know, all right, at 10 a.m. on that day, the stream gauge actually was showing where that flood stage was at that moment in time, was about half of where it maxed out. So give me some context of what it is that we're seeing in this particular time step. I'll come back to my notes right here and show you just a few other things that I had noticed to give you an idea of what we can see with some of this higher resolution imagery. So over here, I noticed that there was actually this residential complex that was being built just over the last couple of months. It was anticipated to finish. And it looks like right over here, we can see where there's some water that's pulled up around that area. And it does appear that was at least a little bit underwater at one point that week. We can see also that there are some structures in this area that appear to have been lost during the flood. And there was one other area down here where we can see this small riparian buffer of just a couple of trees along the banks of the river. Most of those appear to have washed away as well. So it gives us a way to really easily, from a safe distance, say what has been happening here in the wake of this event. Now, something else that I think can be kind of helpful here is when we see a change like this one, where in this case, this structure floated downriver a certain distance. In Lens, it's very easy for me to also create measurements. So right over here, I can find my measurement tool, and I can see that if this traveled that distance, then there I can see that was 329 feet. So it gives me a way to quantify a little bit more what some of those changes actually look like. Now, the other thing that I find really helpful here, this is a site that's had a lot of development in recent years leading up to this, and a lot of different folks who have been buying and selling property. And so when we are thinking about like who actually is managing these sites and who's most closely affected, I can also use parcel data to help get some insight about that. So this is an overlay that we use from a company called Regrid. And so they provide up-to-date parcel ownership information. So here I can see who owns these different parcels and where those fall. So it can be really helpful for different types of emergency management, but also for things like managing private land conservation. If you need to know who may hold a conservation easement or something like that, it can be really helpful to see how those are changing over time. And there are lots of different things that we can toggle on here as well. Things like USGS flow lines and other pieces of information that help us get better context of what it is that we're seeing on the imagery. So one other thing that I know folks often are really curious to see, and I'll come back over here with details for this image, is what we can do with the data once we have it in Lens. So aside from all the different kinds of analysis and observation that we have built in, you also can often take these images and download either a PNG or in some cases also a geotiff of these images, so you can use them for other types of mapping projects. We also do have an option for streaming that data into GIS tools. So for instance, when you have, let's say even like a more public facing type of dashboard or something like that, it can be really easy to integrate these images in there as well. So moving on to one more example here, another North Carolina site. This is one from the eastern part of the state that shows us, again, as I was mentioning before, some of those CAFOs where we have concerns about runoff from agricultural waste. So this in particular is in Cape Fear River Basin. This is one where we see both chicken and hog operations. So here you can see that the hog operations right here have these what are known as lagoons, which is where the hog waste is stored in liquid form. Often is also sprayed on fields, which is something that I'm pretty certain we can see in this center pivot right over here. So something I want to show you here is that in particular, this is one where I know a lot of folks are really interested in managing these sites to make sure that folks are following proper regulations, to make sure they're protecting clean water by working with different types of state agencies, especially. So here I've gone along and made some different notes of things that I can see. And let's say, for instance, over here, I saw a poultry litter pile that had been cleared. So again, a before and after comparison here, where we can see what this looked like before, and then after it had been cleaned out, we can see it's right down to dirt. Something I can also do to share out the information that I've gathered here is to create reports from these notes. So what I'll do is just click that button right there, and then I can see that site that I was looking at. I can also select a particular image if I want to see the higher resolution one that we were looking at before, which I believe was from, let's see, I think it might have been this MAPE image from summer of 2022. So there we could see what that looks like. And again, our source information is all going to be really transparent right here, so you can see that. In the notes, we also can see who made these different observations, when they made it, what they saw, and any attachments as well to help to give context to what we're seeing. So again, makes it very easy for us to share that insight out with our communities. Going to a different example here of a different type of freshwater concern that sounds like a lot of you guys do deal with is algal blooms. So this is Lake Winnebago in Wisconsin, which is a very large lake that deals pretty much every year with pretty significant algal bloom concerns. So beyond just the imagery that we've been looking at here, we can also use different types of satellite data to help give us insight about what is happening on this landscape in ways that the human eye just can't even see. So over here, you'll see all these different ways that we can visualize change on this landscape. I'm going to go into the chlorophyll layer right here. So this is derived from that S2 means Sentinel-2. So it's a data source that comes from the European Space Agency every 5 days. And so it gives us a way to measure the aquatic vegetation and algal activity on this lake. Coming back into my notes here, I can see that some of my colleagues already have taken a look at this and created some different visualizations of how and when these concerns have been coming up. So Eve, for instance, noticed that in August of 2019, we had a really significant algal bloom that was about the highest it had been in 8 years. So here we can see those bright yellows are where the chlorophyll activity is really high at the time. I'll show you over here with this analysis tool, I can also select that entire area. And if I want to know something like how has the chlorophyll index changed over the last 2 years, I can run that analysis, and right here, it's already run all the data from every 5 days of the last 2 years to give me an idea of what that trend has been. So here we can see that it was really low in late fall of 2019, and it looks like it kind of started popping up in early summer. So going from something like that to, so say a June to October, something like that, I can grab my before and then my after and see, sure enough, that has started to pick up. One other note here that's kind of cool is that you'll see we do map out any cloud cover, so it helps to make sure the analysis is really just focusing on what's happening on the ground. Taking this even a step further, something that's really helpful is that we can not only analyze areas that we know we want to look at, but as I mentioned earlier, we can also get automated alerts that help us to focus our efforts on the ground. So in this case, we set up an automated alert using our lookout function, where we can see where there have been certain algal blooms detected at certain times. So this is one where we can create a new alert type right here. And if, let's say, I wanted to know when the chlorophyll sensing went above a certain threshold, like say about here, on any amount of this lake, I want to know as soon as that happens, you can set up an alert just like this, and then have that running in the background so that we can get alerts to, for instance, say, even just a couple of weeks ago, we had something pop up here, and we can see in red the area where it was, where we can see the impact was above that set threshold. Sure enough, we can see that tracked with higher chlorophyll values. There are lots of different ways that we can use this beyond just algal blooms. This is great for looking at development and encroachment on more sensitive like forests and headwaters. There's kind of an unlimited range of possibility here for things that are going to have any sort of effect that we can measure on the ground. For folks that do things like carbon projects, we've got carbon data as well. We've got land cover information. So for anything where it's helpful to get some extra capacity, extra prioritization, I think those are some really helpful tools for us to use. I'll pause there for a moment. I see we do have a handful of questions in the Q&A. Kate, as I mentioned, has been helping to get us set up here, and I will hand it over to her now. We can get into anything else that you guys want to see. So again, keep those questions coming if there's something that you want to take a little bit of a closer look at, different types of issues you're interested in. But this is sort of how it all works, and hopefully that's a helpful overview to give you an idea of what's possible when you're going to monitor your own watersheds.
Yeah, thanks, Jake. That was a ton of great examples. And hi, everyone. I'm Kate, another member of the team here. Help a little bit with Q&A. As a reminder, please feel free to drop any other questions and comments you have in that Q&A tool. And Jake will answer as many as possible here. We do have a few. I know you covered quite a few examples, but we have one specific one here. How would you use Lens to monitor the implementation of cover crops in a watershed?
Ooh, that's a good question. So for that in particular, I think that the analysis tools looking at vegetation cover can be really helpful. So let's go and take a look at one of our agricultural sites. I'm trying to remember off the top of my head where there's a good one that shows cover cropping, but let's start with this one. There may be some cover cropping here, but it'll still kind of show you a little bit of what I'm getting at. So this is a site in Romania where there's a lot of different fields that are being managed by different landowners, right? And so we can see that at different times of year, they might be harvesting or planting certain crops. So looking at the true color imagery, everything just looks kind of brown, right? If we come over here and take a look at the vegetation data, again, this is from Sentinel, so that's that satellite that produces data every 5 days for us. I can very easily see where certain fields are fallow or currently in production. Let's go to kind of like let's try a late spring, early summer image here to see sort of what that is looking like at a particular point in time. So again, this is where we're doing a cloud mask. So the gray areas are where we're not going to be using that data for analysis. But if I wanted to select, let's say, a certain field and see when that was planted or when that started to grow, I can select that right here. And over the last year, give us a measurement of the vegetation health. And it looks like that was actually pretty high even in early spring, which is interesting. So let's take a look at that. Sure enough, that looks to me like cover cropping, where cover cropping or potentially a perennial crop. I would have to look into some of the higher res data and have a little bit more context for what's being grown in this particular area. But that's the kind of thing where at a certain point in time, if there are certain crops that you're looking for that are photosynthesizing and showing that vegetation health, it's going to be really easy for us to look at it using an approach like this.
Awesome, thanks. We have a couple more. Let's see. Is there a way we can share the things we see in Lens with community partners or for educating the public?
Yeah, definitely. So I think especially for those of us who are working in areas where we are trying to engage with communities about issues around water quality and watershed health, I think that can be really important. So as an example, for this site in North Carolina, if I wanted to share out, let's say, some of these different images that show the effects after that flood, I can come over here to grab those individual images. I can also create reports or do screenshots. But something else that I think can be really helpful as well is to show, in some cases, we can even create these links that we can share or embed on our websites. And let's do one of these, for instance. So right here, I'm just seeing a comparison of some of the USDA imagery, right? If I come over here to this share property map, I can copy a link that I can share with anybody so that they can go in and they don't even have to log into Lens or know anything about how to use this, right? They can just kind of see those images that I've pre-selected. I can even add some notes to give them a little bit of understanding of what they're looking at. And so they can toggle around and sort of see this for themselves and interact with that. So there are a few different ways. I think this is probably the easiest and most interactive way to do that. For folks that are a little bit more interested in some of the data reporting and the actual results that you're going to be reporting out, some of the reporting functions are probably the best way to do that.
Nice. And while we're talking about reporting, there was another question here specific to that. Do the reports automatically generate citations for the image sources?
Yes, great question. That's something that we always make sure to include, and I'll come back. I think it was, let's see, right here is our report from the CAFO site in North Carolina. So this one here is going to show us by default the source information with the like the correct attributions. That's a good note that sometimes when you do share out imagery publicly, especially from some of the commercial vendors, it's important to make sure that you're keeping those. So we try to make it as easy as possible for you to see what those should include, so that like how to reference things like the resolution and the data source and all of that.
Great. And let me know if you covered this one, but this person's interested in how we would monitor implementation of regenerative agriculture practices, such as no-till farming.
Yeah, I think that's likely going to come down again to some of the vegetation layers. So I would approach that in a similar way to the cover cropping question. I think that ultimately, like I said at the beginning, the approach that you use when it comes to remote monitoring are going to be driven by the questions you're trying to answer. And so what I would think about is, what is the indicator that is going to give me the most useful insight here? Is it about whether or not a certain area is like has vegetation activity at a certain time of year? Is it about identifying certain types of crops that maybe you can make out on some of the higher resolution imagery? So that's sort of how I would think about that. A couple of these different tools in combination may especially get to some of the specific questions you're after. I think this often comes up with things like invasive species as well, right? Like if you have, if you're looking at a landscape that has a certain invasive plant, often those have a longer growing season than native vegetation. So using that knowledge, we can see if there's a spike in vegetation cover early or late in the growing season. That may be an indicator that we have one of those species gaining a foothold in the area that we're looking at. So a couple different ways we can use these tools to help us get an understanding of different types of vegetation communities and ecosystem health.
Okay, here's a little bit of a different one. Can imagery from lens be used for enforcement to agencies or in legal action?
Yeah, so good question as well. I think that the design of our reporting, again, really tries to be as specific as possible with some of the source information. So that when you're trying to verify what you're seeing on the ground, and when you report that to different agencies or different stakeholders, that's going to be there for you to use. One thing I'll point to as well is that we have a ton of support documentation on our website. And so if you have specific questions about things like using different imagery sources in a legal context, that is something that we have some guidance around here. So things like, again, more specific attributions and, you know, how to make sure you're following best practices around the use of commercial imagery. Tons of information there, but this is also a great resource for lots of other questions that folks may have, just our support upstream.
Awesome. I have a bit of a specific one here, but I think it's something that you can speak to. This person is working to document violations of a particular permit. This one is NPDES, if you're familiar, in a very isolated area. They've seen large amounts of foam on the water twice during flights, and foam is a violation of that permit. How easy would it be to look at the receiving water body every day over the last year to see how many violations occur? Thinking it would need to be a good resolution. So this is a really specific question, but
yeah. So this is where we're going to get into. Let me pull up again my little comparison image here to give. This is where we're going to really get into the weeds on specifications of imagery, I would say. So think about, first of all, what is the resolution that you need to be able to identify the issue that you're encountering? For something like that, it sounds to me like you're probably in the sub-meter resolution ballpark. So something like 30 centimeter resolution image, if you can get your hands on that. Zooming in here, you can get an idea, like over here, for instance, is a 1.5 meter resolution image, over here, 0.5. So if I had questions about when this landowner maybe put this fence and this shed on their property, I might be interested in one of these data sources as opposed to something like this. Now, aside from resolution, things like frequency of image capture are going to vary among these vendors. So among the most frequent ones that we work with are going to be Sentinel. So like I mentioned, that's every 5 days. USDA imagery for most that's available just in the continental US, and that's for most states going to be every 2 or 3 years. So huge variation there. With the commercial data, bit of a more mixed bag in terms of the frequency. A lot of these are going to be sort of responsive to demand in the market. So think of who else is out there interested in commercial satellite imagery, right? Often that's going to come from things like real estate, insurance, oil and gas. So where there's a lot of overlapping demand for that, you'll see a higher frequency of imagery. But if you want to be certain that you are getting imagery at a certain time and place, that's something we can do through a process called tasking. So that's where you would say, for instance, like, hey, Airbus, like I want your imagery of this particular place, this particular time, here are the specs I'm looking for. And so that's something we can support as well. It's just going to be a trade-off between how much control you get and what the cost is, because the what we call archive imagery, like we were showing you earlier, is essentially taking data that's already available, that's already been captured, and set at a lower price point. So that's sort of how I would think about some of those questions around frequency and availability. How important is it to you to get a certain type of data at a certain time? I would say, for most areas in continental US, even in really remote areas, I would say like around or about like quarterly sub-meter imagery is pretty standard in my experience. And then for certain areas where there's just more demand, especially in more like suburban geographies or places like that, maybe much more. But with the archive, it's always going to vary.
nice. And for questions, that are really specific, or if we don't quite get to like the specific use case you're looking at, definitely reach out to the team after, because this is like the stuff we love to dive into.
Yeah.
Yeah, let's see. Another one here. Could I add my whole watershed to lens?
Good.
Question,
Well,
Brett.
obviously, watersheds vary enormously in terms of area, right? So first thing I would think about is basically like what's a scale that is useful to you for monitoring. I think like if you were to put in, let's say, the entire Mississippi River Basin, like that would not be helpful probably to most people. The other thing I would think about is basically is a more tactical question. So can you break down the areas that you're interested in into certain priorities? Because this actually gets back to the imagery availability question. The way satellite imagery is captured is in individual tiles, which usually are about 26 square kilometers. So to give you an idea, let's see if I can find a good example of this. Maybe this might take me a second to find a good one, but let's say maybe something like this. Yeah. So this obviously is not an image I would want to use, right? This comes from the extended archive from Airbus. The reason we make this available is that the extended archive basically means that these are images that were captured, but were not necessarily like in tip-top shape and didn't quite make it through the quality control process. The reason we sometimes make these available in Lens is that because these tiles are so large, so like here, for instance, you can see just a clip of one that's that whole size. Our area of interest is just a little blue polygon right there. So it's got a lot more to it that we're not interested in. So if our teeny tiny area happens to not be covered in clouds, maybe this would be useful. But to prove my point, you get a certain size of image, right? And because we're trying to use imagery in Lens for easy verification, we typically want one snapshot when we're looking at it. We're not usually stitching together different images. So when you get really large, chances are smaller and smaller that your whole site is going to fit into one of these. So I would say if you do have a large watershed and you want to see everything, best practice is going to be to break that down into components that you can sort of look at separately. But there is no limit in Lens on how many sites you can add. So if you want to add either 5 sites or 5,000 sites, it does not really matter as long as you have those broken up into individual properties, as we call them, that are going to be pretty manageable and help to maximize your chances of getting good imagery.
This might be a good time on that line of thinking to touch on pricing. We have a couple questions here just around our business model. Is it subscription based, and how we handle pricing?
Yeah, absolutely. So I'll pop over here as well just to show our some of the different options that you've got. So like I said, we kind of design Lens for nonprofit organizations primarily. And so the idea here is that as an organization, you can sign on to get access to Lens for either a year or on a monthly basis. And you have a few different options for those subscriptions. So we've got a standard subscription as well as a more lightweight version that are going to vary on things like how many user seats you might need for your team and what types of features you want access to. So for instance, in that standard plan, you would have access to things like the automated change detection, the tax parcel data, the ability to do tasking with custom satellite imagery, and some of the streaming into GIS tools. So a couple of those features are available in that one. I'll also mention, since I'm going to venture a guess that a lot of folks on this call probably are in this boat, we do also have a Lens for Good discount program, which provides reduced pricing for nonprofits. So once you get into the subscription that works best for you, you have full access to all different functionality in Lens. So that's going to include as many sites as you want to monitor. Do all the processing of public data, all the analysis and reporting is all built in. And the only additional cost along the way is if you do want to order commercial imagery, that's sort of pay as you go as much as you want. We have some organizations that focus just on using the public data and don't order a ton of imagery, and others that want imagery for all their sites as often as they can get it. So up to you to determine how much that is useful. But in general, and I'll come back over to our imagery comparison here, we keep the pricing pretty simple for the most part with the imagery. So any of these sub-meter resolution data sources are going to be a flat 6 cents per acre. So if you've got a 100-acre site, pay $6 and you get that image. So that's how the imagery pricing works.
Awesome. Here's another one. Can the GIS web map tile streaming integrate with ArcGIS online web and story maps?
Yes, it can. So that's another for folks that may have more specific questions about the GIS integrations. We do have a whole support doc on that for like the exact process of how you can get that into any of your Esri tools as well as QGIS if you're working in open source. So yeah, very easy to set that up for folks that are working those platforms as well.
Excellent. Here's one on surface water temperature. Are there any data sets in Lens for surface water temperature?
That's an interesting one. We've talked about that and have not specifically added a temperature data set. I know, especially for marine applications, that can come up. Sometimes. There's a ton of different types of environmental data out there that, of course, I think can be useful in a lot of different applications. We specifically keep all of the different data layers that we have in our Lens library here. So, we're adding new things all the time. Like actually this canopy height data set is one that we just added today. We've got different types of land cover information for certain, specific types of issues and geographies. And so you can kind of come through here and see what's most useful to you. But something that I'll share as well is that there are, of the 250 some odd organizations we work with, folks are using Lens for lots of different applications. And so we're always learning of new things that folks want to monitor in Lens. So if there's something in particular where, say, a data set like surface water temperature is useful to you, it's usually pretty straightforward for us to be able to add some of those in as we build out our library. So we always love to hear about different use cases that folks can think of where we might be able to prioritize, helping you get access to some of these things.
Could you speak a little bit to what kind of training we provide when people are onboarding, or what kind of like skill level you might need to get started here?
Yeah, totally. I think this is something where, in my experience, you have a very wide range of comfort levels and experience with geospatial data tools at a lot of organizations. And so we try to make this as easy as possible. Like we have some folks in here who are GIS professionals, and we have some folks in here who might even be like volunteer board members for an organization that are really uncomfortable using new technologies. And so we try to make it as easy as we can. I really have to give a shout out to our engineering team, who I think does a great job of building some really, really intuitive tools within Lens to help folks really just kind of get in and get started right away. But we do have plenty of training available as well. So I showed you our support documentation. We always keep a ton of educational resources out there for folks that want to sort of go through step by step and learn all the details of everything. But we also, when you get started, provide live onboarding trainings and can provide additional support when you have to staff or something like that. So definitely something we think is really important, making sure that everyone knows how to make the best use of Lens. I think comes down to making sure that we're providing training that is really accessible to the whole team. So something we absolutely offer.
We want to get to a few more questions, but I'm cognizant we only have a couple more minutes here till we're going to wrap. Before I ask more questions, is there any resources you specifically want people to know, any next steps folks should be aware of in terms of how to get in touch with us?
Yeah, maybe Kate, if you can drop my contact information in the chat would be really helpful. And then also I'll point you guys to the resources on our website where we have a lot of stuff in here. Kate, if there are a few specific links that you want to share in the chat as well related to some of these resources that maybe are more specific to our watershed protection work. We've got, for instance, things like a how-to guide on using Lens for monitoring flood impacts, information on all of the steps of ordering and accessing commercial imagery, even some things like guidebooks for algal blooms, demo examples for different types of projects, from managing wetland bird habitat to coastal restoration. We've even got some of the examples that may be familiar from the last 30 minutes here, but some of the different pollution concerns around things like ag runoff, coal ash, dam removal. So yeah, there's a ton of different ways that you can use this kind of stuff. So there's a lot of resources on the website for sure. And of course, happy to talk more about what you're specifically working on.
Awesome. Dropped a couple of those links in the chat as well. Folks want to click on those. Great. We're almost coming to time. Maybe we can squeeze one more in. We had a question around industrial sites and how you use Lens to monitor land use change on industrial sites.
Oh yeah. Let's go. Without knowing exactly what type of industrial site you're talking about, I'm going to go with an example in here that I think is really powerful, which is actually the largest industrial site in the world, is the oil sands operations in northern Alberta, so specifically Fort High. Just to give a sense of scale, this is going to take a moment to load up. It's a huge site. But this is one of the areas that's been mined pretty heavily for oil sands. So there was specifically an area over here where I'm just going to look at some of the Sentinel data to show this, but it was a huge tailings pond that's over a mile across, where we saw a breach of that, where there was runoff from the tailings pond into the surrounding area that was causing some measurable water pollution. So this is something where, in this case, again, I'm using just the Sentinel data. So this is freely available imagery. It's going to be coarser resolution than some of the other stuff we could look at. But here you can see where that has expanded, right? So that's the area I'm interested in. Zooming out, there's that tailings pond. So it sits kind of above the surrounding forest. And so that tailings pond is sort of what's producing a lot of the waste that's coming into there. I'm trying to do a little bit of screen Tetris here. So I'm going to measure the distance across. Like I said, it is more than a mile across, like that is 9,000 feet of tailings pond. And this particular area that's cleared because of that breach is 1,800 feet. So again, quite large. Something that I think a lot of people struggle with monitoring industrial sites is that these are not accessible to civilians most of the time, right? And especially when we often, as enforcement agencies or watchdogs, have this relationship to these sites where we're not usually welcome out onto them. It can be really helpful to get this imagery because otherwise, how would we know what's happening here? But over the years, this is something that we can see as this enormous site has been expanding in different areas. Like this part over here is a bit of a newer exploration. There were some drilling pads I was able to notice down in this area on this different image. Just in the interest of time, I'll kind of skip over that a little bit. But if anyone's interested in taking a closer look at some sites like this, or like I mentioned, coal ash is a huge one that I know in the southeast in particular is a really big concern. There's a lot that we can do to monitor some of these sites from above just by getting access to some of the images that are already available out there.
Yeah, so good to know. And I know you can dive in on this stuff. Like we could go down lots of rabbit holes here because there's so many use cases. So yeah, if you asked a question that we didn't get to for any reason or have follow-up, please let us know, reach out to the team. As you exit the webinar, there'll be a really quick survey we'd love for you to take, just if you have any thoughts or want to give us some feedback. We're always open to that. And yeah, thanks for coming, everybody. Anything else in your mind, Jake?
No, I think that covers it. Thanks again, Kate, for getting us all set up here and keeping things moving with the Q&A. And yeah, for folks that want to take a closer look at some issues in your own watershed, give me a shout anytime. I'd be happy to take a closer look at some of the things that you're working on, and I hope this can be helpful to you. So thanks for joining us.